Okay, let's talk about the chain rule. Out of all the different rules for derivatives, the differentiation rules, this is the one that gives students the most trouble. And it really comes down to understanding function notation. The chain rule says if you've got yourself a composition of functions, a function inside another function, then the derivative of that composition is the derivative of the outside evaluated at the inside, leaving the inside alone, times the derivative of the inside. Or if we write that in Leibniz notation, dy dx could be rewritten as dy du times du dx. It's kind of like if we pretended these were fractions, see how you could cancel out the du's and you would get dy dx. These are not fractions. Remember, derivatives are not fractions. This is not dy divided by dx. That's the derivative of y with respect to x. But if y is a function of u, and u is in turn a function of x, so let me write that out in here. This here is saying y is some function of u, but u is really a function of x. Oh, I shouldn't give it the same letter. Say some g of x. And I want to know how quickly is y changing with respect to x. Well, then I would just see, well, how fast is y changing with respect to u, and multiply that by how fast u is changing with respect to x. So what we really have here is y is f of g of x, because u was g of x. Then y prime would be f prime evaluated at g times g prime. Okay, let's do a quick example. And this is not the best example to start with, but it's the one we have here, so let's do it. First off, I could solve this using quotient rule. So maybe, like as an aside, we'll do that using quotient rule. But if I want to use chain rule, I want to think of this as 3x squared plus 1 to the negative 2 power. So remember, a negative exponent just means you've moved across the fraction bar. So you should be able to look at that and see that these are the same thing. Okay, now I have a composition of functions. I've got a function here that's inside another function. This guy here would be my outside function. So when you're looking at chain rule, you always want to think inside and outside. So I'm going to be very explicit here. I'm going to write these out in terms of f and g, just for this one example. So f of x here would be the outside function, which is just junk to the negative 2 power. And g of x would be the inside function. So let's write this. Outside. Everything here in parentheses. I don't even need those parentheses. This is my inside function. Then h of x can be thought of as f of g of x. Like, just think about function composition here. Like, let's think about this for a minute. What does that mean? That means rewrite the function f, but now instead of writing x, every place you see an x, replace it with whatever g of x is. So that would be junk to the negative 2. That's f. F is take your input and raise it to the negative 2 power. What are we raising to the negative 2? What's my input? 3x squared plus 1. So all I've done, I haven't done any derivatives yet. I've just rewritten h as a composition of functions. Then h prime, by the chain rule of x, is f prime evaluated at the inside. Leave the inside alone. So just take the derivative and just pretend you're just taking the derivative of x. But then multiply that by the derivative of the inside. So h prime of x here would be, how do we take the derivative of junk to the -2? What would f prime be? That's just power rule. That -2 would come down times x, and then -2 would drop down by 1. So that's my derivative of the outside. Derivative of junk to the -2, the -2 comes down, leave the inside alone, and my new exponent is -3. So I've done this part. What I've written right there is this: the derivative of the outside, leave the inside inside, times, we had g of x was 3x squared plus 1, so g prime of x, the derivative of 3x squared plus 1 is just 6x. So this right here is f prime evaluated at g, and this is g prime of x. It's a good place to stop on this first one.